When developing an application, you are typically working with many different kinds of data in different structures, each with a different behavior and needs. However, if you were to use different naming conventions for every single structure, your application would descend into chaos. The pejorative term spaghetti code is an apt description, meaning the source code is impossibly complex and tangled like a pile of pasta. To avoid this mess, you can define an object interface. An interface specifies what methods a class must implement, but doesn't say how those methods should be implemented. There are similarities to an abstract class, except that an abstract class can have both scope and methods defined. In an interface, every single method is by default abstract and public. A class can implement more than one interface at a time, as long as those interfaces don't have conflicting method names. Interfaces can also have constants, which will be available to any classes that implement it. Interface constants cannot be overridden or defined. Overriding will be covered in greater detail in the next video. Finally, an interface can extend another interface if you desire. The practice of sharing a common application programming interface between classes is known as polymorphism. In the example application, let's define an interface that both the current class and potential classes must implement to describe. When naming the interface, try to be as generic as possible, yet specific enough that it makes sense across all contexts. A model is responsible for managing data, storing and retrieving entities, and containing business logic. This aptly describes what the address class is doing and what future classes may be doing at a high level, so create a new file called class model.inc. Class model.inc. While an interface is not a class, it's very similar and can be loaded with the autoloader. To define an interface, start with the keyword interface followed by the name. Shared interface for interactions. Define two base methods. Load, a static method to load from the database given an address ID and return the appropriate model, then save to save to the database. The reason why load is static is that you cannot anticipate what class should be associated with a row. Instead, you can add logic to the load method to return the correct class for the row and call load statically. This will work because even though address is abstract, you're not instantiating it. Static function load, which takes an address ID. Load a model, param int address ID. Next, function save, which will save a model. Save, then switch to the address class. You want to make the address class implement the new model interface, so after the name of the class, add the following. Implements model. If you were to save and refresh the demo, you would get a fatal error as the address class does not declare the abstract methods from the model interface. Before you continue, I will introduce a new concept, final. The final keyword prevents child classes from overriding a method. You can also declare a class as final. If you do, then it cannot be extended. In this case, we will want the generic address to be able to load and save and to prevent its children from loading and saving in a different way. At the end of the address class, add a final public static function load, which accepts an address ID placeholder, followed by a final public function save. Add documentation. Param is an integer. And add documentation. Save the address. For the time being, leave these declarations blank, as this functionality will be included in a later video. Next, I'll describe another object-oriented programming technique, overriding methods, properties, and constants.